Hey everyone, in this video we will discover how do we use a DISC method and how do we use a shell method and when to use either method. So these are the general techniques to determine when we should use either method. So if you're someone that haven't fully understood the methods yet, don't worry. If you follow this step, you might get a better idea on how each method works. The first method to do is, first you draw lines from the curve to the axis, to an axis, so either axis that encompasses the area that is being revolved. Alright, so this will be the first step. So for example, I have this graph here, and let's say I have an area here that is R, right? Okay, so this quadrant here is R. If I want to rotate it, so let's say the first question one would be rotate R 2 pi about y-axis. So what we do is we will draw lines, right, from the curve to an axis, right, that encompasses the area revolved. So let's think about it. We draw the lines downwards, right? Because the area is at R, we have to draw the lines downwards. We cannot obviously draw the curve to the y-axis. It wouldn't work. So we notice that the lines are parallel to the y-axis, which is basically parallel to the axis that they're revolving about. So here comes the step number 2. If lines drawn are parallel to, actually if line drawn are here parallel to axis of ref, this would then give us the shell method. If lines drawn are perpendicular to axis of ref, then we would have the DISC method. Alright, why is that so? Let's take a look at this example, right? Question 1. We rotate R 2 pi about the y-axis. You notice that the shell method is an open ring, right? It's an open ring. Okay, let me try to draw. It's an open ring where it's still like a cylinder, just that it's like a rectangular strip that is bent to form a ring. And therefore, if you compare it to the graph here, you notice that this is kind of our thing, right? So this would be, let me try to draw a better one. So we have a strip down here, so it'll be something like this. So this is just half, it's just like one half, obviously there's a front part. So this is the whole idea, right? See, there's this empty space down here. So this would be the shell method, correct? Because if you notice, if you have to rotate, right, the volume kind of goes like this whole loop around, but it doesn't cover the center. So this is where we know that it's the shell method. And that's why if the lines drawn are parallel to the axis of revolution, it will be the shell method. Let's say we do another question, same graph. Now we have another area. Let's say we have this area here as Q. Alright, so let's say this area here is Q. So now the second question is, we rotate Q 2 pi about the y-axis. Okay, what do you notice? So first step, draw the lines from the curve to an axis that encompasses the area revolved. So we know the area is on the left, right? So we can draw the lines downwards. So let's say we draw the lines downwards. What do you notice? We get perpendicular lines, right? So let's just draw one line. So we draw one line here. We get perpendicular lines. So all the lines drawn are perpendicular, and therefore it's the DISC method. Why is it a DISC method? Because if we were to rotate this fully, we will get something like this, right? This will be the volume of this will be the figure of that is revolved about 2 pi about the y-axis. So we kind of get this like whole figure. Then notice if we slice it, we get discs, right? So let's say we take this as an example. So from here to here, you get this whole thing will be a complete disc, and therefore we'll use the DISC method instead. Alright. So that is just one way of us figuring out whether is it a DISC method or the shell method. Alright. So yeah, obviously, if we were to do the more questions, right? So let's say we rotate r 2 pi about y-axis, about x-axis now. What happens is this. So we know that this will be, okay, so we know that the first one will be shell. The next one would be disk, right? So what do you notice about r now for the question number 3? If you rotate r about the x-axis, now you realize that it is perpendicular to the x-axis. Therefore, this will be the disk method. Going to question number 4, we now rotate q 2 pi about x-axis. Okay, then what we notice is that if you rotate q 2 pi about the x-axis, the lines are basically parallel to the axis, to the x-axis, right? So you notice it's parallel to the x-axis. Therefore, this will be the shell method, right? So yeah, this is one big way to actually figure out whether it's the disk method or the shell method. Okay, so just a quick summary. We have about x-axis, and then we have about y-axis. So we have the disk and shell method, so I'll break them down into 2 parts. Okay, let me just extend this line again. All right, fantastic. Okay, so this will be the disk method. So I'll draw something like this. So I'll draw lines perpendicular to axis. Then I'll write here shell method, lines parallel to axis. Okay, so for the disk method, if you're rotating about the x-axis, it will be pi y square dx. For y-axis, it will be pi x square dy. For the shell method, about the x-axis, it will be 2 pi xy dy. For the y-axis, it will be 2 pi xy as well, but this time around, it will be dx. So yes, there we have it. The differences between the disk and shell method and when to use either method.